Let's look at a Yarn use case with an example. Yahoo was the first company to embrace Hadoop, and this became a trendsetter within the Hadoop ecosystem. In late 2012, Yahoo struggled to handle iterative and stream processing of data on the Hadoop infrastructure due to MapReduce limitations. Both iterative and stream processing were important for Yahoo in facilitating its move from batch computing to continuous computing. After implementing Yarn in the first quarter of 2013, Yahoo installed more than 30,000 production nodes on Spark for iterative processing, Storm for stream processing, and Hadoop for batch processing, allowing it to handle more than 100 billion events such as clicks, impressions, email content, metadata, and so on per day. This was only possible after Yarn was introduced and multiple processing frameworks were implemented. Let's look at some of the advantages of Yarn. The single cluster approach provides a number of advantages, including higher cluster utilization, where resources that are underutilized by a framework can be consumed by another. Also, lower operational costs because only one do-it-all cluster needs to be managed. And reduced data motion, as there's no need to move data between Hadoop Yarn and systems running on different clusters of computers. The Yarn infrastructure. This is responsible for providing computational resources such as CPUs or memory needed for application executions. Yarn infrastructure and HDFS are completely independent. The former provides resources for running an application, while the latter provides storage. The MapReduce framework is only one of many possible frameworks that run on Yarn. The fundamental idea of MapReduce version 2 is to split the two major functionalities of resource management and job scheduling and monitoring into separate daemons.